Hello friends, welcome back to Rising Mathematics. In this video we are going to see the concept of differentiation on time scales. Before seeing the actual definition of derivative of a function in time scale, firstly we will see the concept of say t to the power k, where t is the given time scale, and we are going to use this concept of t to the power k to define derivative of a function in time scale. So if for a given time scale t we have supremum of t is some finite number, then the set t to the power k will be t minus this interval which is open from row of supremum t and closed from supremum t. So when we have supremum of t is some finite number, then t to the power k will be t minus, we are eliminating left scattered supremum point of the given time scale from this t. So that set will be t to the power k. And if we can't determine supremum point of the given time scale, then supremum the set t to the power k will coincide with the time scale t. Now we will see two examples. So as a first example, consider a time scale t which is the set of numbers 2 to the power n naught. Now this time scale will have infinitely many points, and the set n naught is set of natural number union 0. Now for this time scale we have the set t to the power k will coincide with 2 to the power n naught, since here we can't determine its supremum. As a second example, consider a time scale t containing finite numbers say 1, 3, 5, 7 and 8. Now here clearly 8 is supremum of this time scale and 8 is left scattered. So t to the power k will be set containing numbers 1, 3, 5 and 7. So here we are eliminating this left scattered supremum for the given time scale to form a set t to the power k. Now we are ready to define the concept of derivative of function in time scales. So definition: assume that f is a function defined from time scale t to set of real numbers, and let t is some point in the set t to the power k. Now if f delta is the number provided it exists such that for any epsilon greater than 0 there is a neighborhood say u of this point t, which is in this form: u is equal to open interval t minus delta t plus delta intersection with time scale t for some delta positive, for which we have, that is for this number we have this condition mod of f of sigma t minus f of s minus f delta t multiplied by sigma t minus s. So this mod is less equal epsilon times mod of sigma t minus s for all points s in this neighborhood of point t. Then we call this point f delta as delta or Hilger-derivative of a function f of the point t in the given time scale t. So this is the definition of derivative of a function in time scales. Further note that a function f defined from time scale t to r is said to be delta or Hilger differentiable in set t to the power k if the number f delta t exists for every point t in the set tk, and the function f delta, which is again a function from time scale t to r, is said to be the delta or delta derivative or the Hilger derivative of the given function f on the set t to the power k. So this is all about the concept of derivative of a function in time scales.